So we're going to go through, hopefully kind of briefly, we realize there's a big human impact to this. The point today is just kind of recap. It's been a while. I know maybe some of us blocked a lot out. If if this is something traumatizing to you, then please feel free to skip it. But the point is just to kind of remind ourselves of the progression and clear up some of the fogginess and the blurriness of memory that comes with time here. So, all right. Everything began in 2018. The sequence kind of began back in April, really. April 13th, 2018 is when we had the first lava lake overflows of the year. You can see that, that bottom panel here, lava was flowing across what's about 2/3 of Halemaumau crater. This was actually a series of overflows in the 25th, 26th. The previous one was a few days before that. And during that same interval, the whole floor of Pu'o'o, 12 miles away, was also getting uplifted. So all of that to say that the volcano was really pressurized. If we look at this cross-section, USGS cross-section here, we see that of all the different plumbing parts of the volcano, this South Caldera chamber, the Upper Halemaumau chamber, the rift zone, everything, all the system, all the way from Pu'o'o to the summit, everything was completely pressurized to the point of spilling out the top, essentially. So April 30th was when it really was obvious that it was essentially the point of no return, as far as I'm concerned. When we saw the first major domino that set things off, and that was the collapse of Pu'o'o after a 4.2 earthquake on April 30th. It set off a kind of pinkish, grayish cloud there you see photographed that was seen across a lot of Lower Puna. And people saw that, they knew something was going on at Pu'o'o, and soon afterwards is when the earthquakes actually followed. So we'll get to the earthquakes here, but here's a before and after of Pu'o'o, April 18th and May 3rd, showing that upper part of the crater floor up in here. Fully collapsed, right? You actually had two different pits, and you can see the new collapsed pit engulfs both of them. After the fact, they came back and measured this. I want to say over 1,000 feet deep. A pretty dramatic difference at Pu'o'o there. As a little footnote, there is evidence of a little eruption pre-collapse. This is on a west flank of Pu'o'o. This is looking towards the east. The lower east rift zone would be off in that direction over there. There's this crack with steam coming out of it on the side, and there was one spot the USGS came here and released this photograph of, looks like fresh lava had come out of that crack. Not very much, not very far, but you can see the pressure was enough to actually burst up out of the ground at Pu'o'o, and then essentially burst down the ground, burst underground across some barrier. And so here's that similar cross section. Here's that summit caldera complex. East rift zone going this way, and a blockage might have existed somewhere over here prior. And once that broke with the April 30th event, the magma then was able to reoccupy the lower east rift zone, moving past lots of other stored magma bodies, some of which it pushed up to the surface, and that's what drove the beginning of that eruption right in there. I've shown here on the bottom the tilt plot from those times for those of you guys that haven't been following with us for that long. The scale in microradians here on the side goes from -200 to 0 to 200. So this is actually 1,000 microradians in total, top to bottom. So the green line is Pu'o'o. We saw April 30th, a big collapse of Pu'o'o right there. And a big inflation, actually. That was probably that little eruption event. Then a collapse. And then we saw on May 4th, a big earthquake on the south flank, the 6.9. And it was actually after that event, after this 4:30 event, that we saw the blue line on the summit start to come downhill. That's the deflation of the summit, right? Which first is the draining of Halemaumau lava lake, and then the collapse of the crater walls. Then eventually it becomes collapse of the caldera with a stepwise up and down starting on the 15th or so. Okay, this is the initial activity. Like this is essentially that month of earthquakes leading up to the eruption. And you can see that there are times that we had bursts of lots of earthquakes underneath the summit. Right, we knew that magma was coming in. We saw earthquakes flaring off an upper east rift zone and an upper southwest rift zone at the same time, as well as under the summit, over and over and over. The south flank was actually pretty quiet much of that time, right? Until that 420 event. And afterwards, we saw a bunch of earthquakes proceeding from that area down towards Leilani Estates, where lava then emerged on May 3rd. Right? You see the south flank earthquake there shown is not the one that's to come the next day on May 4th, so we'll come to that here in the next interval. But to recap that first week saw 15 fissures cross 3 miles, 5 kilometers of the subdivision. Lava took 36 homes in the first 5 days in Leilani Estates and Lani Puna Gardens. See, that's more sluggish, slow-moving lava that was the first to come out, but still across such a wide area that it had a devastating impact there at first. And of course, of those first 15 fissures, Fissure 8 was the most active and did flow out and consume a good amount of those houses. At the summit, lava lake started to drain. Here's a picture on May 6th of a much deeper pit. The lava had just been overflowing up on this upper rim a few weeks before that, 1 week before here. Right? So lava started draining out fairly quickly, easily visible by May 6th. We'll show you guys the thermal time lapse here of that draining sequence on May 6th. May 7th now. Actually, for May 2nd, 3rd, 4th, 5th, 6th, 7th. So it was going slowly the whole time, just more obvious as time went on. So the next week of seismicity was dominated by that big earthquake at 6.9 right through here, when a flank moves about 20 inches. And that essentially is what allows the next phase of the eruption to occur. I mean, magma had pressurized so much that it was actually essentially in the rift zone, pushing on the south flank. As magma was draining from the summit into the rift zone, it exerted additional pressure on that south flank, and it seems like the combination of all those things set off the south flank with that 6.9 earthquake. So from research after the fact, they believe that this blue area was the area that slipped here. Some of the areas slipping more than others right through here, and you see everything, all these arrows are GPS vectors on land pointing towards the ocean of the direction of movement of the south flank there. Another graphic showing the rift zone itself as a schematic colored bar here. And it's showing the coloration of where there was a net loss of material and a net gain of material. And so as this earthquake moved to the south flank and centered here, everything moves off in this direction. All the magma that had been built up in this area, upper east rift zone in the summit, was then able to flow down and accumulate in this area. So net gain in the lower east rift zone, and net withdrawal of the upper and middle east rift zones and the summit of Kilauea as well. Okay, a couple graphics here. That's a little busy, but focus just on the top one first here. This is an image from IRIS Consortium, Educational Consortium, and they're showing here a structure looking from the center of the island off towards the south, right? So Mauna Loa is up here, Kilauea summit's right there. Showing a melt zone from the mantle coming through the base of the mantle and tectonic lithospheric plate here, crust. And all of these black lines are faults in that shallower, brittle crust there. So the magma coming up through all of that with these interaction of the fault zones and the summit occurring right in here. So I've essentially tried to Frankenstein an image together down here that puts all this together, right? So the black lines are the faults right here on the bottom, the south flank moving off in this direction, and the magma coming from the summit through the rift zone is making use of these vertical, subvertical areas of the faults, right? And that's what the rift zone essentially is. Another way of explaining the rift zone is this area of pulling by gravity that's opening it, and then it being injected by magma as well. It's the magma using the fault zone as a pathway in these areas. And that's what that rift zone really is. So the south flank moves. That allows the rift zone to open even further beyond what had already happened at Pu'o'o, where magma had gone towards Leilani. The ground had already been opened. Lava was already coming out when the 6.9 happened. And when it did, that essentially opened the valve, but it opened it far enough upstream that it took a little while. So that next week was mostly dominated by activity in the lowest east rift zone. This is Fissure 17 you're hearing. Those exploding sounds were constant. And this is the fissure that put out the stickiest lava. I gotta turn that sound off. It's a little too triggering, maybe still. But yeah, that's where that stickiest lava came out, and there was actually some stored lava that got pushed at the very, very far edge, but that's more of the chemistry story. We'll leave that for some other time, and we've discussed that in the past as well. Keeping to our chronology here, at the summit, collapses begin on May 15th in earnest with large, dark ash plumes. The first few of those actually go up 30,000 feet and issue some aviation alerts in response. But ultimately, that was the peak of it, and there were no larger explosions beyond that, mostly gas driven from the magma that was built underground. Down in the Lower East Rift Zone, as that large surge of magma from the summit region arrives down in the area, fresh lava surfaces. We were up to 23 fissures, 8 of them erupting at once. Fast-moving flows reached down to the ocean, just east of Mackenzie Park. Take 42 more homes in total between Leilani, Lanipuna, and Pohuiki area down in there. In that time, we had these methane blue flames filmed coming out of the cracks. This is a drone image from the USGS that's looping through here, right? In a fissure and looking down towards the coastline far away, and really interesting how fast the lava got down there. Our friend Ikaika talks about having seen big albizia trees floating in the water ahead of that flow that were just charred on the outside. The lava pushed them so fast downhill and out of the way. So that was the third week. The fourth week, Fissure 8 reactivated. 6-mile long flow, 10 kilometers, consumes 153 more homes. Some of the other fissures keep spattering more in a Strombolian activity, but really it was Fissure 8 that you see here. That was the story of the rest of the eruption, beginning in this fourth week here. And I'm generalizing a lot. I'm just really trying to make some big picture reminder here, yeah. All right, so week 5, the lava channel is formed. Lava funnels down Kapoho in 2 days. Then the whole Kapoho area gets taken out beginning here. 319 homes that week. Kapoho Bay, Green Lake, Waiapai tide pools, Champagne Pond, all in that 5th week, end of May to the 1st week of June. There it is, Fissure 8, since rechristened Ahu Aila'au. Big lava channel. Just one part of that what ended up being 7 to 8 mile long lava channel pouring into the ocean there. All right, summit collapses continue. This is June 6th, week 5. This is I thought this was more interesting to see now in the hindsight of the last 4 years of what's happened at the summit. You can still see the parking lot over here on the left side of the image. So this is not fully through the full caldera collapse yet. The whole down drop block is yet to form all over here. But you do see that inner pit of Halema'uma'u, that lowest part of the collapse starting to form already there. Still collapses were ongoing. Meanwhile, weeks 6 through 8 down in the Lower East Rift Zone were a little more stable. Once lava had overrun Kapoho and established an ocean entry, it widened the ocean entry across a 3-mile, 5-kilometer width. It extended the coast outwards half-mile, 800 meters. By this point in time, we're up to 580 total homes lost. The peaks of the fountains come around this time at about 260 feet or 80 meters. Right there, you can see that fluid river of lava issuing from the vent there. Okay. There is that 8.5-mile lava channel that was in that later part of it when it had rediverted. Maximum speed, this has been discussed, but the number I have written down here, 17 miles an hour, 27 kilometers per hour estimated max speed. That's I think the USGS measured. Some people have other similar measurements and came up with similar values. As far as estimated depth, 20 to 80 feet, 5 to 15 meters, varying depending on where along the path of the channel there. All right. Panoramic view of it. So panning from Ho'ela'au around Green Crater up over there to the south. Okay, so the next couple weeks, end of June, first 2 weeks of July, we started to see these lava islands, lava rafts, moving downstream, and eventually they blocked the channel, diverted the flow, and the flow went around the west side of Pu'ukapoho, Green Mountain there. And that unfortunately caused lava to overrun the Kuokala School, Halanui Warm Ponds, a whole new 2.5-mile, 4-kilometer path of the ocean. And that's because a lot of these pieces were getting broken off from the channel walls we were seeing, and a lot of these channel walls were getting undercut, and chunks would fall off, and you can see them getting rafted downriver there. And sometimes you'd see them emerge out of the lava like we saw in that first frame there. So that gives you some idea of the depth in some areas there. And there, Behovita Halanui, there's what it looked like after the lava overran it. Okay, this is Cosmo SkyMed, partial caldera collapse here, a view from space, showing over time the collapse of the caldera. See it coming in there. So as it gets to the end, I can point out the features we now know. There's our down drop block all over there. There's that inner pit of Halema'uma'u, which has all been filled by now, and now we're actually lapping on to these areas over here on this edge right over here. I can play it one more time. You can see how that down drop block forms later on in the process, right? It kind of grows from a smaller radius to a slightly larger radius to a slightly larger radius, right? We see that this innermost deepest pit collapse first, and then it was this next slightly bigger area, and then it was eventually that whole area. All right. Ahu'aila'au, Fissure 8. By the beginning, last 2 weeks of July, coming into August, started to fluctuate. We started to see surges following some collapses. 2 to 3 hours after the collapses, the lava would overspill the banks. During the lulls, the lava might harden in the channels and slow the flow. Here we've documented in at least one area the relative difference in elevation of lava in the same channel from the same point of view. So you can see here different aerial views of empty and full. Coming down to the river. See much of that eastern part of Kapoho entry had actually cooled off already, but the pattern was one of more fluctuation. We'd worry more when these surges would occur. The lava would break out and establish a new path out and possibly take out more stuff, but fortunately didn't happen beyond the one time. All right, the last 4 weeks, the last month of the eruption, August 3rd to September 6th, the fountains dwindled fairly quickly once the summit collapses ended. August 3rd was the last collapse. The channel drained for 3 weeks, still putting lava into the ocean by Pohoiki Bay, still threatening the bay. Ahu'aila'au collapsed, refilled, collapsed a little more, refilled a little more. And ultimately it was over by the beginning of September. Still, it was a stressful time. Even as lava drained towards Pohoiki, to think how far might it come and would it take out the boat ramp. At the time we were concerned about the lava being the main aggressor there, right? And what happened after the fact was the sand is what really blocked it all off from the currents. So the aftermath, this is Leilani Estates and Ahu'aila'au. This was taken shortly afterwards, right? So since then, there's been some little bit of revegetation on the margins, especially. But you can see here the grid of the subdivision disrupted by this new natural feature that's cutting off all the roads here. So in the aftermath, a lot of gas venting in a lot of areas, even uprift, as well as eruption sites. That went on for a while. It's diminished a little bit, but it's still something that we'll have more learned to live with and has gone away completely, as far as I understand. Some satellite images before and after. This is Leilani zoomed in on the right into Ahu'aila'au area right through here. The grid beforehand, view after, and the zoomed out view here. So really it was that eastern part of Leilani Estates that was overcome by lava. Of course, everywhere else in Leilani was also overcome with the stuff falling from the air and the earthquakes and the gas and everything else that went along with it. Lots of branches we could go and talk at length about, but I'm just trying to keep it at a high level here as far as overview. Lamipuna Gardens on the left, Kapuho on the right. Before and after, you see how much more dark is on the image there. It's really heartbreaking to see these areas. All the community there displaced, right? And not a huge amount has changed since. All right, a little bit more of the recap here. Flows by week. We have here yellow was that first week of eruption, moving to orange. The second set of fissures that occurred in that lower part of the rift there. Third week, ocean entry. Fourth week, pushing east towards Kapoho. The fifth and 6 weeks, right, where it stays. You can see we get into the purples in the later parts as the lava delta is expanding to the side. Recapping the sequence of eruption there. We can look at another view here. This is our time lapse of thermal images. So about one a day or so. Shows the progression of what was flowing and hot at what point in time, even as it spread around and covered more and more ground. Lava flow thicknesses, this is the preliminary map. So I'm missing some of the data here. I think there's a better one that I could find, but this is what I have right here right now. So you can see that in many areas where we have the greens, we're talking up to 50 feet in the greens. We're talking in the yellows up to 80 feet. Orange is up to 100 feet. The darkest red here from 180 to 919 feet. So in the offshore areas, 919 feet. Huge amount of lava building a giant ramp offshore to extend the coastline out and further. In the online areas, you see most of the thickest areas are these oranges here in Kapoho. 80 to 100 feet in some of those areas. Otherwise, you're looking at yellows, 66 to 82. So some really significant buildup of lava there, so it's not like you can dig down and excavate anything. You have to essentially start anew on top and deal with the fact that this thick flow is going to hold heat longest where it's thickest as well. We did have the Nautilus live expedition publish this image here, showing in red the addition of lava offshore. Right? So you see a little bit here at the Mackenzie area. See one lobe in the east for that initial couple hole lobe that came around Green Mountain to the north and east, and then you see that second Pohoiki Halanui lobe that came in second after that diversion there. So everything matches up. Total homes lost, I think the number I got to was 716 permitted. A lot of other things unpermitted that we haven't seen research exactly nail down. This is Dane's map. Go ahead, Dane.
Yeah, that wouldn't be exactly permitted. It would be they had a tax map key. They were taxed by the county as having a residence on them. Some of those were unpermitted, but they're recognized anyways, right?
Right. That's the number we're hearing from the county also.
Yeah. Right, and I do believe that number because I think my number of permitted homes ended at like 580. And then the rest were unpermitted, and then it got grayer and grayer the further you went into it. But yeah, that's roughly the number. But I heard people say oh, it's got to be 1,000 with all the unpermitted places. And I'm like, no, that I don't know where they would be hiding, because the satellite imagery we had was pretty good.
And there is research coming out on this that's gonna accommodate for all structures and not just homes. So something it'll try to account for all the other stuff that's maybe not
kind of weird.
Extra house, carport, whatever, all those things. Anything
greenhouse that somebody sleeps in on the weekend. Or even stuff like that. Weird things.
Even just greenhouse. I mean, even all those things should be counted at some point also as well. And so there's different ways of counting. And so I think that there is a different way of counting. That's we're still awaiting publication of the research to share officially what those estimates are. But yeah, a lot more than that. 30 miles, 50 kilometers of road covered, 875 acres of new land, 13.7 square miles, 35 square kilometers covered, 1 billion yards, 1.2 cubic kilometers erupted, over 60,000 earthquakes over the whole sequence, 4,400 over magnitude 3 in those 3 months. Sounds crazy to say now how much happened there, right? Here is Pohoiki, right? The central image right in here. You can see that original bay for any of this eruption. It's coastline, all the way back, lava's going in the ocean up here in this image right here. So afterwards, everything has just been totally filled. The bay itself still exists as a bay, but you can see all the sand that's piled up in there. We've discussed this in the past as well. Different view of the sand blocking the boat ramp. Thermal ponds now behind the beach. So leave it at that. Before and after, we've shown different views of this in the past. In blue was the profile of the caldera before collapse, in red afterwards. And here's the beginning and ending images of that sequence that we showed you guys, that satellite view from. So to wrap it up here, we'll just show you guys that one final time lapse. This is a time lapse taken of the whole caldera collapse from April until August. So you see the lava lake overflowing here at the beginning. You see ash clouds coming up. You start seeing the ground drop out and vanish. Then you start seeing the slivers that are still leaning against the edges start dropping down as well. And eventually there's our down drop block. Before and after comparison. Same view. It takes a while to train your eye to see what's the same, since there's so much different in there. But all right, that's a short recap there. Short visual recap of what happened in 2018. There's obviously a lot more we could do. We could take it in lots of different ways. that eruption lasted 3 months. So not that we're going to be recapping 2018 constantly over the next 3 months, but there's plenty of time to pull things out here and there and talk about other aspects of it, right?